Hey everybody, this is Mr. Stevenson. The last couple classes we've been looking at proofs and the derivation of the Pythagorean theorem. And today we're actually going to look at applying the Pythagorean theorem to different situations. So quickly we're going to go ahead and review. Pythagorean's theorem says if you have a right triangle means one of the angles is 90 degrees, right? That's what that means. And let's say we label the legs A and B, right? Remember these are called legs. And you label the hypotenuse as C, then Pythagorean theorem says if I do A squared plus B squared, then that will equal the hypotenuse squared. So what this allows us to do is if you know either of the two legs, you can figure out the third leg. For example, here's a very simple example. This is a right triangle. Let's say this is 2 and this is 3, and we want to know, hey, what is this other side? Then I could say, okay, well, I know that the Pythagorean theorem says 2 squared plus 3 squared will equal, C squared. We don't know what C is. So 2 squared is 4, 3 squared is 9. That equals C squared. 4 plus 9 is 13. So I know C squared is 13, therefore C, we take the square root of both sides. C is the square root of 13. And if you want to know exactly what the square root of 13 is, you can go to your calculator and say square root of 13 is about 3.61 if you round to 2 decimal places, right? So that side right here is about 3.61. Right, and just a big hint here is this C value should always be the longest side, right? The side opposite the 90-degree angle. All right, so let's look at another example. Sometimes this can be used to measure certain things about real-world objects. Let's pretend we have this tree situation. It's called the tallest tree in the world. It's called Hyperion, and it's a coastal redwood in California, USA. That's actually where I am right now, is in California, although these trees are up in the north farther than I am. The surveyor comes here and he knows that he's standing 40 meters away, right? He's standing 40 meters away from the tree. And he uses a laser rangefinder to measure its height. He finds that the height is 116 meters, right? So he figures out that this height is 116 meters. Let's change this question. So we might want to know how long is the laser from beam to the top of the tree. So we might want to know this distance here, right? More practical application is like, let's pretend this tree is going to blow over and we need to tie a rope to the top of it coming down to hit the ground, right? And we want to know, he knows he wants to tie it here. He wants to know how long does this rope have to be, right? That could be another example. So the Pythagorean theorem shows us that, okay, well, this here is the 90-degree angle down here on the bottom, right? That's the 90-degree angle. So that means the side we want is the hypotenuse. So we could do 116 squared plus 40 squared, and then we will get this side here squared, right? So we can go ahead and do that on a calculator. We can say 116 squared is 13456. 40 squared is 1600. That equals C squared. If you add those two together, you get 15,056 meters squared. And then don't forget you have to take the square root of both sides. So then to find the C, right? Because right now we have C squared. So I'm going to take the square root of 15,056. No, stop it. And we get 122. Therefore, C is 122.7. You may be asking, if you are thinking properly, shouldn't this be plus or minus, right? Because whenever we take the square root, we should have plus or minus. Because think about a simple case. If I had x squared equals 4, there are two numbers that squared equal 4, right? 2 squared is 4, and so is negative 2 squared. Right? So really the solution to this equation is x equals plus or minus 2. However, we're talking about distance, and distance can never be negative. So we do not need the minus piece. We can only take the positive piece. Right? So we know that this laser went 122.7 meters. Don't forget your symbol there. Or what that means is if it was the rope, the rope would need to be 122 meters long. All right, let's look at another example, maybe a little bit less context. let's say we have, let's not do a square. I'll do two more examples for you. Let's say I have a triangle, and I know that this one, I know that the hypotenuse is 12, and I know that one of the sides, so here's my right angle, I know one of my sides is, I don't know, 7, and I want to know this length here, right? So whatever the situation, let's pretend it's that. The equation I would have to set up for this is I would have to say 7 squared plus x squared equals 12 squared, because the hypotenuse always has to be over here by itself, right? So you can see how this one's going to take a little bit more work, not a whole lot, but I would end up with this if I square those numbers. I would then have to subtract 49 from both sides, right? I'm going to get x squared equals 144 minus 49, which is 95. And then I would take the square root of both sides, and I would get x is the square root of 95. So come over here, square root 95, and you get x is about 9.75. Again, I'm going to use these squiggly equal signs because it's approximately. And then, you know, if there was a unit, you'd put a unit there. All right, let's look at one other example. Let's say I have a square, right? This is a square, meaning all the sides here are equal. Let's pretend I know that the hypotenuse is, I don't know, give me a number. Let's say the hypotenuse is 35. Then the question would be, what would the side length be, right? What are these side lengths? Let's call them A, right? They all should be A. Well, if you just look at it, you can see that this makes a triangle, right? And a right triangle because it was a square. So I know that a squared plus a squared should give me 35 squared, right? In this case, I know the general Pythagorean theorem says this. In this case, a and b are the same because it's a square. So I know this is true. A squared plus a squared is just 2a squared. 35 squared, let's do that over here. What is 35? Okay, now 35 squared is 1,225. I can just solve this equation by dividing both sides by 2, and I'll get 612.5. And then I can take the square root of both sides to get a is approximately, if I take the square root of 612.5, I get 24.75. Right, so I know that, oh, the side length of the square is 24.75. All right, so that's what we're practicing today, is using the Pythagorean theorem. What I'd like you to do is we're going to do practice 1. I'll write down on ManageBack the specific problems that you should be doing from practice 1, okay? And then you need to upload your work onto ManageBack. Okay, good luck. Please reach out if you have any questions.